In the previous class, we were discussing the Zener diode as a voltage regulator. Okay, we were discussing this topic, Zener diode as a voltage regulator, right? So the shunt voltage regulator circuit, okay, the shunt voltage regulator circuit, we can see, okay, here, right? We have seen this in the last class. So what do we have? If you consider only this resistance and diode, okay, you know that Zener diode we are using in the reverse bias. So positive terminal, okay, right? That is the what do you say? The okay anode, okay, is towards the negative and the cathode is towards the positive. Basically, the diode is reverse biased. Okay, so this is the reverse bias connection. Of course, a resistor to protect the diode and then load across the Zener diode, because Zener diode maintains constant voltage. Okay, that is what we are expecting at the output of regulator. We have seen all this. Okay, so basically here, what do we have? V naught is equals to Vz, because these two are in parallel, and KCL at this node, I is equal to Iz plus IL. Okay, this also we have seen in the last class, right? Now here we will consider two cases. First case, okay, when input varies, how the output voltage remains constant, right? That is case 1. Case 2, when load changes, load RL, when load changes, how the output voltage remains constant. Okay, these two cases we will study, right? Okay, so it is like this. Suppose, okay, father has say father wants to give you 50 rupees. Okay, irrespective of whether he has 53, 55, 54, how many rupees he has with him, still he is giving you 50 rupees. Okay, right? That is okay, that is something like when input is changing, he is having 54, 53, 55, but still he can give you 50 rupees. Okay, that is the first part, varying input voltage. Second case, okay, right? Suppose your father wants to give 50 rupees. Now you go, you will get 50 rupees. If your brother goes instead of you, okay, he will also expect the same, right? Okay, suppose your father wants to give you 50 rupees and to your brother he will give say 30 rupees. It is not acceptable, isn't it? Okay, so that is similar to analogous to second case, which is okay, regulation with varying load. Irrespective of what you are connecting at the output, still you want the output voltage to be constant. Okay, yesterday I have given you motor. Suppose if you connect a small 5 volts DC motor at the output, okay, right, still the output should remain 5 volts. It should not be okay changed because of the load that we are connecting, right? Or if you want to charge, suppose you connect charger, okay, right, say the output terminals you want to use to charge your mobile. Okay, when you connect your mobile phone, if this voltage is dropping, okay, right, that is not a favorable situation. Okay, so we want the output voltage to be constant irrespective of changes in input voltage or changes in load. So case 1, so simple maths, this also we have seen in the previous classes, that is what will be IL Ohm's law, V naught by RL. Okay, V naught by RL. Just now we have seen V naught is Vz. So IL is Vz by RL. In place of V naught, we are writing Vz. Okay, then the same equation, it is written here. Okay, so what happens when input increases? Okay, this also we have seen earlier. When input increases, okay, when input voltage increases, I increases, right? What about IL? IL is Vz by RL. So IL is Vz is constant, RL is constant, so IL is constant. Okay, So here IL is constant. So when V in increases, when V in increases, I increases. Okay, IL is constant, so IZ will increase, right? IZ will increase. Fine. So this is the operation which takes place. Let us see point by point. If V increases, then the total current I increases, but IL is constant as VZ is constant. Hence, IZ increases to keep. Okay. So this increases. This is constant, isn't it? Okay. So this will increase and this will be constant. Okay. To keep IL constant. Next case, what happens if input voltage reduces? Okay, this also we have seen. When input voltage reduces, I reduces, IL is constant, so IZ will reduce. Okay. Similarly, if V decreases, then I decreases to keep IL constant. To keep IL constant, IZ decreases. Okay, right. Important point that we have to remember here is all this is valid as long as the Zener current is in between, okay, as long as the Zener current is in between IZ min and IZ max, okay, that is the condition which has to be considered, okay. So but in both cases, as long as IZ is between IZ min and IZ max, then only you can expect Vz to be constant. When Vz is constant, V naught is constant because V naught is Vz. Thus, the changes in input voltage get compensated and output is maintained constant. Although input is changing, output is constant. Okay, isn't it? We don't want fluctuations in supply, right? We want a constant supply. Next, regulation with varying load, the second case. Okay. Now, when we are considering regulation with varying load, okay, for better insight, we will consider Vin as constant. Input is constant, only the RL is changing. If both are changing, we don't know what is happening, right? So, to understand that better, when RL is changing, we will consider the case when Vin is constant, right? So now again, let us see the outline and we'll go into the points in detail. So second case, first case is over. When input was changing, how output remained constant. Now we are going for the second case. When input voltage is constant, but RL is changing, okay. So that is regulation with varying load. Varying load means RL is changing, right? Okay, so what happens when RL changes? Now let us see. If RL decreases, what will happen to IL? Anybody? Simple logic. What happens to if RL decreases, what will happen to IL? Anybody please answer? Fast. If RL reduces, what will happen to IL? First of all, what is V naught? V naught, is it constant or varying? Answer. 455. Who is 455? Number 455. Fast. Yes. Okay, next A7. What happens when RL reduces? Number A7. Okay, listen carefully. When RL reduces, okay, we know Zener diode will maintain constant voltage across it. So V naught is anyway constant. When RL reduces, V naught is constant means IL has to increase. Okay, IL is V naught by RL or VZ by RL, right? VZ is constant. Okay, we are going for second case. We are going for second case, but still the equations are valid. Equation is valid. Only thing is, in second case, RL is changing. Okay. So IL is VZ by RL. So when RL reduces, because VZ is constant, IL will increase. Right? So what happens? What happens here? Okay, Ohm's law you know very well. Current is I is V by R. IL is inversely proportional to RL. So when RL reduces, keeping V in constant, second case, okay, second case, keeping V in is constant, okay. So when RL reduces, V in is constant, obviously, okay, Vz is constant, property of Zener diode. So Vz is V naught. So V naught is also constant. So when RL reduces, IL has to increase. Okay. But what about this particular current I? Okay. See here, V in is constant, second case, right? And Vz is also constant. So I is also constant. Correct. Okay. But when RL is reduced, IL is increased. Okay. So correspondingly, what happens is IZ will take the responsibility and IZ will reduce to keep I constant. Okay. So this is what happens. Let us see that point. As input voltage is constant while the load RL is variable. Okay. Vin is constant. V naught is Vz, constant, property of Zener diode. Then for constant R, I is constant. Okay. Vn constant, this voltage constant means I is also constant. What will I be here? I will be Vn minus Vz by R. Okay. Vn minus Vz by R. This also we have seen in the previous class. So Vn is constant, second case, Vn is constant, Vz is constant, R is anyway constant. So I is a constant, right? And I is IL plus Iz, same equation. Next. So if RL reduces, what happens? I told you IL increases, and to keep I constant, Iz decreases. Okay. But again, this will work only when Iz is in between Iz min and Iz max. Okay, right? The output voltage will be constant. Next, what happens when RL? Okay, see here, first case we considered RL decreasing, what happens? Next, we will consider what happens if RL increases. Anybody will explain? One of you will, let us make it interesting. Just tell me what happens if RL increases. If RL increases, what will happen to IL? Please answer. If RL increases, okay. First one of you please answer.
Decreases.
If RL increases, IL reduces. If IL reduces, IZ will, I is constant, isn't it? So when RL increases, then IL reduces. When IL reduces, IZ will what? What will happen to IZ? Yes? Okay, I will answer. So when RL increases, okay, because output voltage is constant, current has to reduce, isn't it? Okay, Ohm's law. So when RL increases, IL reduces, right? I is constant. So when IL reduces, IZ has to increase. Okay. And the constant output voltage is maintained. Okay. But the condition is again IZ should be in between IZ min and IZ max. Okay. Let us see that point. Similarly, if RL increases, IL decreases. Okay. To keep I constant, IZ will increase. But as long as Iz is between Iz min and Iz max, okay, then only the output voltage is constant. We have seen the graph also, right? Thus, the changes in the load get compensated. Although the load is changing, RL is changing, We have taken changing means either it will increase or decrease. So each case we analyzed. Okay. So both cases we have come to a conclusion that V naught will maintain constant because of the property of the Zener diode, right? And output is maintained constant. Okay. So this is the Zener voltage regulator. Okay. Now let us see what are its limitations. Limitations means drawbacks. Okay. Let us see the drawbacks. First of all, large power loss in series resistance. This is series resistance. Okay. There is current flowing through this series resistance, right? Okay. And this is loss. See, this is input. Across the Zener diode, what you get, which is the same as across the load, is the output. Okay. So this is loss, right? So large power loss in series resistance. Okay. Anyone has doubts? Yeah. Can you explain? Can you ask your doubt? I couldn't hear. Okay. Anyway, so large power loss here. Next, power loss. See, suppose somebody is doing business. Okay. They got loss. What do you say? He or she is inefficient. They got loss. So they are not efficient. So poor efficiency, right? Loss means poor efficiency. Okay. Next, DC output voltage changes due to Zener resistance. Okay. There is a Zener resistance. Okay. Which every material has resistance, and because of that property, okay, right, there is also Zener resistance. So every material has resistance. So Zener diode also has some resistance. Okay. That is responsible for some slight change in the output voltage. It is not exactly constant. We are approximating it to be constant. There is some slight change, and the reason is the Zener resistance. What exactly happens there? Okay. We have seen IL changes, Zener current changes. Okay. Just now we have analyzed. If IL changes, IZ changes. Right. Okay. Now that IZ multiplied by the Zener resistance, okay, will be the Zener voltage, right? Ohm's law. So Zener current is changing. Changes in IL produces changes in Zener current. So IL is changing means IZ is changing. And Zener resistance is non-zero. It has some value. So because of that, the output voltage is changing. Okay. Third and fourth together we can combine, and we understand that because of IL is changing, IZ is changing. Okay. When IZ is changing, IZ into Zener resistance, okay, is also changing, right? So that will result in slight changes in the output voltage. Okay. The output voltage is not adjustable. Means suppose you are connecting a Zener diode of 5.1 volt. The output is 5.1 volt. Okay. You cannot get 6.2 out of that. You cannot tune it. Okay. That facility is not available. Next point, cannot be used for large load currents. If you see, okay, this is the sample problem which we will see next. The current is in milliampere. Okay, the Zener current is usually in milliampere. So we cannot use this for large load currents. Okay, right? So next what we will do is we will solve this question number 6. Okay, right? Already asked 2 times in the previous exams. Okay. So I want all of you to first see the question, think about it. Okay. Right. So a Zener voltage regulator circuit is to maintain constant voltage at 60 volt. Right. Okay. So first what you need to draw? You need to draw the circuit of Zener voltage regulator. This one, resistor, Zener diode, load resistor. Okay. Resistor, Zener diode, load resistor. We are drawing that circuit. Next, Let us see the first line again. A Zener voltage regulator circuit is to maintain constant voltage at 60 volt. Okay, right? So what is the output voltage here? Anybody? From this, what do you see as the output voltage from first line? Vz is output voltage. Okay. So see this first line, and what do you think is the output voltage of this circuit? Anybody answer? Okay, I will explain again. See here, Zener voltage regulator circuit is to maintain constant voltage at 60 volt. Okay, right? Where you get constant voltage in a regulator, it is at the output. Okay, so it means that this 60 volt is the output. So 60 volts we are mentioning at the output. Next, over a current range from 5 to 50 milliampere. Okay, let us read the sentence in continuation. A Zener voltage regulator circuit is to maintain constant voltage at 60 volt or a current range from 5 to 50 milliampere. Where is this current range considered? Okay, it is usually Zener current. Okay, there they are referring to the Zener current, isn't it? Current ranging from Iz min to Iz max. This current is referred in the question. So Iz min is 5. What is Iz max? I want you to answer. Okay, I don't want boring class. One side I keep on talking. Okay, that should not be the case. Iz min is 5. Basic, simple, common sense. What is Iz max? It is there here. You can see it on the screen. What is Iz max? Anybody please answer? 5 to 50. Okay, right? Suppose a person got, what is his range of marks means? 5 to 50 means his minimum marks are 50. What is, sorry, minimum marks are 5. What are the maximum marks? Students, what happened? Answer, one of you please answer. Okay. So what is happening here? It is, they are giving range 5 to 50. So minimum is 5, maximum is 50. Okay. So from this we understand Iz max is 50, Iz min is 5, unit is milliampere. Okay. Next, the input supply voltage is 200 volts. So 200 volts is Vn. That Vn, this one 200 volts. Okay. Determine the value of resistor R. They are asking find R. Okay. Next, what else they are asking? Find R to connect in the circuit for voltage regulation from load current IL 0 to IL max. Right. So they are telling IL is ranging from 0 to IL max. Means they are telling IL min is 0. Okay. What about IL max? They didn't tell. Then they are asking the maximum. What is IL max? The maximum possible value of IL. What is the value of IL max? Okay. So they are asking two things here. Determine the value of resistance R. First, this R they are asking. Okay. And what else they are asking? What is the value of IL max? Okay. These two they are asking. Okay. To understand this, let us consider some simple logic. Okay. Right. Now, suppose a father has 100 rupees with him. Okay. And he has to distribute among two children. Okay. The first child will take 90 rupees. How much does the second child get? Please answer. Very interesting. If you understand this, easily you can understand. Simple. See, everything is basic logic. If you understand, then you can understand everything. Okay. Suppose father has 100 rupees. One child has taken 90. He has only 2 children. He has to distribute among the 2 children compulsory. One child has taken 90 rupees. How much does the other child get? Simple. Answer, please. That is sufficient to solve this problem. This much common sense is sufficient to solve the problem. Okay, right? Yeah, please answer. How much will the second child get? Answer fast. Students, quickly answer. 489. Okay, whenever you are answering, turn on mic, answer. Once you are complete answering, you can turn off the mic. Yes, one of you please answer quickly. Don't waste time. Nobody is present? Okay, if you answer only, you are present. Yes. Yes, yeah, 460. 460 answer. Number 460. Who is 460? Okay. So anyway, I'll explain, right? Okay. Next class onwards, all of you must answer. Okay, I will put it in the WhatsApp. Those who answer will be marked present. Okay. Right. Anyway, your attendance is recorded here. One scrolling will record all the attendance. Okay, right. So I want you to answer. Okay, anyway, so here, see, I is Iz plus IL. Okay. Now let me take this example. Suppose father has 100 rupees. First child will take 90. Second child will get only 10. What I want to tell is, if the first child is getting maximum, the second child will get what? Maximum or minimum? Answer. If first child is getting maximum, what about second child? Will he or she get minimum or maximum? Yes. Okay. Right. So it is like this. Father has 2 children. One child is taking maximum. Then obviously the second will get minimum. Okay. Right. So why am I telling this? Because that is important to solve this problem. I is Iz plus IL. Okay. Or we can call it as, right, this Iz, when Iz is maximum, at the same instant IL will be minimum. Okay, father has 100 rupees. First child, if he takes 90, second child will get 10 minimum. Okay, let us say maximum is 90, minimum is 10. Suppose first child will take 10. Okay, minimum. Second child will get maximum 90. Okay, so you can say I is Iz min plus IL max. Okay, you can say I is Iz min plus IL max, or other case. Okay, when this is minimum, this has to be maximum. If this is maximum, this will be minimum. Okay, then only the current I is constant, right? So I, you can take it as Iz max plus IL min, or Iz min plus IL max. Okay, right? So first, to find R, what is R? Okay, let us see this equation which we have already seen. We know I is Vn minus Vz by R. Okay, I is Vn minus V naught is Vz. Correct? Okay, V naught is Vz. So I, you can take Vn minus V naught by R, right? So from this R will be what? From this you can easily calculate R, provided you first get I. Okay. So what are the two formulas for I? One is Iz max plus IL min. Another is Iz min plus IL max. Okay. Now let us see what all are given. Iz max is given Iz min is given, IL min is given. So Iz min plus, Iz max plus IL min we can use to get I. Okay. So what will I be here? Anybody answer fast? I don't want boring classes. Okay. Whatever I work, I keep telling you, enjoy your work, right? I also want to enjoy my work. That is possible only when students answer. Okay. And the class will be interesting. So tell me what is, okay, what is this I? Formula Iz max plus IL min we can use. Iz max plus IL min. 50 plus 0 is 50 milliampere. Okay. Right. So I we got, V in is given, V naught is given, I we got, V in is given, V naught is given. From that we can find R. Okay. I we are putting here, Vn, this Vn 200 we are putting here, V output 60 we are putting here. R will be 200 minus 60 by 50 into 10 power minus 3. If you simplify, you will get 2800 ohm. Okay. Finding R completed. Second part, very easy. Okay. They are asking what is the value of IL max. Again, the other formula for I we have to use. What is the other formula for I? Okay. When IL is max, IZ will be min. So I is equal to IZ min plus IL max. Okay. I already we found out 50. Okay. Then I Z min is given 5. So from that we can find the I. Okay. So the formula that we will use now is I is IZ min plus IL max. I is Iz min plus IL max. Okay. I we calculated how much we got. Okay. 50. So 50 is equal to Iz min given in the question 5. Okay. 50 is equal to 5 plus IL max. Send the 5 to the other side. We get IL max as 45 milliampere. Okay. So this is the end of this problem. Okay. Right. Next class we will start silicon controlled rectifier. We will start the next topic. Okay. Silicon controlled rectifier, right? So what you will do is you will go through what all, okay, we are discussing. Videos I'll be uploading. You can check again, right? Okay. And any doubts, don't hesitate to contact me. Clear? Okay. First priority for your learning, right? So any doubts so far, students? Is it clear? Any doubts? Students, any doubts so far? No response. Okay. No response means